substrate current. So these are some of the minor factors which are uh, which have to be given due consideration when you fabricate a device. So electric field near the drain can reach extraordinary values with moderate voltage in the short channel device. So when the device length is very small, the voltage applied across the device will be almost uniform. So if you apply a very high voltage for VDS, both the drain and source will be having almost the high voltages itself. So as a consequence, what will happen? The collision of the charges will happen. So when the energy is available to the charge carriers from the voltage, whatever you are going to supply, it will result in collision. And this collision results in impact ionization. And they are called as hot carriers because they generate electron hole pairs. And in NMOS device, the holes are collected by the substrate, electrons flow to drain as usual. So this happens because of substrate current. Current is flowing to the substrate because substrate is also going to be negative charge. Substrate is going to have negative charge. So whatever holes which are generated by the ionization will be attracted towards substrate, whereas electrons will naturally flow through the drain. So this results in formation of substrate current. And substrate current happens because of one phenomenon. In the short channel device, when the electric field is larger, the electrons will acquire energy faster and they will create collision. They will try to collide with the substrate charges in the present in the channel, and they generate electron hole pair. And electron hole pairs in the channel, uh, holes are positively charged. Substrate is negatively charged. Substrate will attract all the holes. They'll be generating what is called a substrate current. Whereas electrons which are generated in the channel will naturally flow towards the drain. So this is the concept of how substrate current is created inside your MOSFET. The resulting substrate current depends on VDS, how much voltage you give at the drain. And this current is flowing from drain to ground. So it is of a great concern because it should not reduce your drain current. Because when drain current is going to reduce, the device will change. The device might go to off condition, right? If majority of current because of ionization is going to ground and only a very small amount of current is going towards your drain, then that is of a great concern for you. So that also has to be addressed properly in your design.